Welcome to homework.
Okay, so problem number 21 states that an electron is bound in a square well of depth U0 is equal to 6E1, 6 times the ground state of an electron in an infinite one-dimensional square well. So U0 is equal to 6E1-1dW. What is the width of the well if the ground state energy E1 is equal to 2.00 electron volts? All right, so now if you refer to figure 40.15 in the text, it gives a very similar problem to this, and it already breaks down what these energy levels are for a finite square well with potential, the barrier energy equal to 6 times E1, the ground state of the one-dimensional electron in an infinite one-dimensional square well. So this is equal to, so the energy of the ground state of a potential, of this potential is equal to 0.625 E1 1dW, where E1 1dW is equal to pi squared h bar squared over 2ml squared. All right, so now we're given that this ground state energy is 2 electron volts. So the units of H and L and M here are going to be in joules per energy. So this energy would be in joules. So we want to go and convert this to joules. So E1 is equal to 2.00 electron volts times 1.6 times 10 to the minus 19 joules per electron volt, which is equal to 3.20 times 10 to the minus 19 joules. All right, so let's go ahead and plug this in here. So we have E1 is going to be 5/8 pi squared h bar squared over 2 ml squared, which is equal to 5 pi squared h bar squared over 16 ml squared. So the problem asks, what is the width of the well if the ground state energy is 2 electron volts? So we need to solve for L. So L squared is equal to 5 pi squared h bar squared over 16 mass of an electron times the ground state energy. So L is equal to pi h bar over 4 times the square root of 5 over me E1. All right, so h bar is equal to h over 2 pi. So we can go ahead and plug that in here to simplify this a little bit. It doesn't really, so L is equal to h over 8 times the square root of 5. Right. Pi's cancel, 4 times 2. Let me clean this up. H over 8 times the square root of 5 over m mass of an electron times its ground state. So now let's go ahead and plug all this stuff in. So L is equal to 6. Give myself some more room. L is equal to 6.626 times 10 to the minus 34 joule seconds divided by 8 times the square root of 5 over 9.11 times 10 to the minus 31 kilograms times 3.20 times 10 to the minus 19 joules. That's supposed to be a 5. So working all this out, you get that the length of the box is equal to 3.43 times 10 to the minus 10 meters, or 3.43 angstroms. Okay, so the one thing to note about this problem basically is that the length of the box, L, as it increases, the ground state energy is going to have to go down. So they're inversely proportional, or inversely related, I should say. So as L goes up, the ground state energy will go up, and as L goes down, the ground state energy, or as L goes up, the ground state energy will go down, and as L goes down, the ground state energy will go up.